Hello, in this video I will introduce the equation of a tangent line and go over all the steps of finding the equation of a tangent line. Uh, what is the equation of a tangent line? It's simply a linear line in point-slope form or slope-intercept form that is tangent to an equation on a certain point. That's all it is. So it's simply a linear line, a straight line, right, in point-slope form or slope-intercept form that is tangent to an equation on a certain point. So for example, let's say you had the equation y equals x squared, and it is tangent at the point 1 comma 1. So do you see this green? The red one represents the x squared, the parabola, and then the green line is the linear line. And that linear line is either in point slope form or slope intercept form. So that's what we're finding. We're just basically finding the equation of the linear line that is tangent to a certain point. That's it. Nothing more, nothing less. So what do you really need to find? What do you need to find the equation of a tangent line? There are a few things you need. So one is you need a slope or first derivative. So if you look at our graph, this slope is positive, right? It's heading to the right. Now, remember, slope is a constant. So remember, slope is, or your m value is like 3, 4, -1/2. So how do you find it is after finding, first you must find the first derivative, right? That's the first step. Then what you want to do is you're not going to get a constant immediately, so that's why you have to plug in an x or y value, or sometimes both, to get your slope or your constant. And I will do an example. Number two, you need to have a coordinate, an x-y coordinate. That's a must. You may only receive an x coordinate. Sometimes they give you just the x coordinate, and if that's the case, simply plug in the x value into the original equation to get the y value before you do anything else. So before you take the derivative, make sure you have a coordinate. If you don't have your y coordinate, simply plug in your x coordinate into the original equation. Okay, and then finally put final answer in point slope form or slope intercept form, depending on the direction. So sometimes your professor might only ask you to put in point slope form, or they actually want you to solve for y and you have to put in slope intercept form. But usually point slope form is fine. And then some review terms. Parallel equals same line. Perpendicular, or also known as normal. So whenever you hear the word normal, it's definitely perpendicular. Two lines are parallel if and only if their slopes are the same. So here's an example. Two parallel lines, the slopes are definitely the same. Two lines are perpendicular or normal if and only if their slopes are negative reciprocal of each other. One way of figuring out is you take the slope of the first line times the slope of the second line. And if your product is -1, that means it's perpendicular. Or you could think of it as the slope of the second equation, m2, is the negative reciprocal of m1. Okay, and then here's some review of equation of linear lines, standard form, ax plus by equals c. Right, this is a linear line. And a vertical line is still technically a linear line, and that would be in the form of x equals constant. And a horizontal line is still a linear line, and that's in the form of y equals c. And then you'll see this a lot. Point slope form is y minus y naught equals m times x minus x naught or x1. So it's y minus y1 equals m times x minus x1. And then the slope form is y equals mx plus b. Okay, so now you have kind of an idea what you need or how to find the equation of a tangent line. Let's do an example. So example 1 says write the equation of the tangent line to the curve at the point y equals x4 minus 3x squared plus 2 at the point or the coordinate of 1, 0. So the first thing I would check is if I actually have a whole coordinate, a whole point, right? We do, right? We have an x coordinate and a y coordinate, so we do. So check mark. We don't have to plug in, you don't have to find the y value because that's given. Now the next step is I'm going to find the slope. So how do I find the slope? Well, I first got to take the derivative. So how do you take the derivative of this polynomial? Pretty simple, right? You would just apply power rule. So the derivative of x4 would be 4x cubed. The derivative of negative 3x squared is negative 6x to the 1. The derivative of a constant is 0. Okay. Then what I'm going to do is plug in my point 1, 0. Because I need to find my m, and m is a constant. Do I really need to plug in my y? Not really, because if you look at this, we only have x's, so don't really have to worry about the y's. So it's going to be 4, and then wherever you see an x, replace it with 1. And you get a final answer of negative 2. Okay, so your m is negative 2. So we have the slope, we have the point. Now we could put it in point slope form. Right, point slope form is y minus y1 equals m. Okay, so we have everything. So 1, 0. This is 1 is like your x1, 0 is like your y1, and then our m is negative 2. So when you put it all together, you get y minus 0 equals to negative 2 times x minus 1. What minus 0 is really 0, so it's just y equals. And then should I guess you could FOIL this out. So this is y equals negative 2x plus 2. Okay, so this is your final equation, and I guess we had to put it in not point slope form, but slope intercept form because we already have y by itself. Okay, so this is your final answer. And as you can see, it is a linear line. Okay, let's move on to example 2. So same idea. Example 2 says, write the equation of the tangent line to the curve at the point y equals 1 over the cube root of x squared at the point x 8, 1, 4. So my first step is figure out, do I actually have a whole coordinate? Do I have an x coordinate? Do I have a y coordinate? Yes, yes. So I don't have to worry about plugging in my x into the original. Okay, the next step is I'm going to find the derivative. So this looks like a big mess, but what if I'm going to rewrite this equation as a power. So this is going to be y equals 1 over. How do I rewrite the cube root of x squared as a power? Well, that's expressed as x to the 2 over 3, right? Now, I don't want to use the quotient rule because it is in a fraction, so I'm going to rewrite this as a negative power. So this 1 over x to the 2/3 can be expressed as a negative power as x to the negative 2/3, right? Okay. Now I can take the derivative easily by using the power rule. So this has a coefficient 1, so applying power rule, it's 1 times negative 2/3, which is negative 2/3 x. And then the power is going to be old power minus 1. So old power is negative 2/3 minus 1, which is 3 over 3. So that would be negative 5/3. Okay. What would I do next? Maybe I should write it as a positive power. So this would be y prime equals. So this negative 2/3 x to the negative 5/3 can also be expressed as negative 2/3 times 1 over x to the 5/3. So that could be expressed as negative 2/3 divided by x to the 5/3. Okay, now we have a complex fraction. So this is your numerator. This is your denominator. So let's clean this complex fraction. So you can rewrite this as negative 2/3 divided by x to the 5/3 over 1. Right? So I'm going to cross multiply. So this would be negative 2 over 3 times x5 is 3x to the 5/3. So your y prime is going to be negative 2 over 3x to the 5/3. Okay, now remember to find slope, it's a constant, so we have to plug in our coordinate. We have x comma 1/4. So what I have to do, I don't really have to plug in my y value because there's no y, so we're good. So maybe I could just plug in 8. So it's going to be negative 2 over 3, and then replace x with 5/3. I mean, replace x with 8. So it's 8 raised to the 5/3. So that's negative 2, 3. And then what is 8 parentheses 8 to the 5/3, or the cube root of 8 to the 5th power? Well, you could just try putting it in the calculator. That's what I always do. Because I don't like check if you could just put in the calculator, and if it's a whole number, you're good. So 8 raised to the 5/3 is, I think it comes out nicely as, yes, 32. So this is, yeah, negative 2. And then 3 times 3, 32 is 96. And then that could be reduced by 2. So that is negative 1 over 48. Okay, so now we have our slope. This is my slope, m equals negative 1 over 48. Now let's put it in point slope form. So it's y minus y1 equals to m times x minus x1. And our point is 8, 1/4. So it's y minus y1. y1 is 1/4. M is negative 1 over 48. X minus x1, which is 8. I'm going to leave my final answer as this. They usually is in point slope form, but unless they want it in slope intercept form, that's fine. But this is fine. Okay, so this is my final answer. Okay, I am going to continue example 3. I think, yeah, there's only 3 examples for this one. We'll do the other examples in another video. So example 3 says, write the equation of the line tangent to the curve f of x equals x cubed minus 3x plus 1 plus x plus 2 at the point 1, negative 3. So what can first step is check if I have a coordinate. I do. I have a 1 x coordinate and a y coordinate, so that's good. I don't have to find the y. The next step is find the derivative and plug in your coordinates. So how would I find the derivative of this? I am not going to use product rule. You could, but I don't want to. Instead, I will just FOIL it out, collect like terms, and maybe just take the derivative of each term, right? So x3 times x1 is x4. x3 times 2 is 2x cubed. And then negative 3 times x is negative 3x squared. Negative 3x times 2 is negative 6x. 1 times x is positive x. 1 times 2 is 2. So let's kind of clean this up. Is there anything I can collect? So x. So I have x4 and then 2x cubed and then negative 3x squared. Negative 6x plus 1x is negative 5x plus 2. Okay, now I take the first derivative. So the first derivative, so the derivative, yeah, I'm just going to apply power rule for each term. So the derivative of x4 is 4x cubed. The derivative of 2x cubed is 6x squared. The derivative of negative 3x squared is negative 6x. The derivative of negative 5x is negative 5. And then the derivative of constant is 0. And then I'm going to plug in my point. I don't think I need my y because there's no y. So plug in your x value. Wherever you see an x, replace it with 1. And then when I put all the work, I get negative 1. So this is all becomes negative 1. So my slope is negative 1, basically. Okay, slope is that, and then my point is 1 comma negative 3. And I'll go ahead and put it in point slope form. So it's y minus y1, which is negative 3, m is negative 1, x minus x1 is 1. So over here, 2 negatives becomes a positive. And then you can just say, you can leave it like this. Okay, so you can leave it like that. If you want, you can solve for y, right? So x plus 1, solve for y. 1 plus negative 3 is negative 2. Okay, so this is 2 answers fine. I mean, 2 forms is fine. Either way works. Okay, so yeah, we'll do the other ones in a different video. Because now we still have to do normal. And yeah, so stop here.